Our final lesson in Topic 3 is theorems about roots. We'll split Lesson 3.6 into 2 days. In the first day, we'll look at a way to find possible zeros of a function using what's called the rational root theorem. To start off, defining the rational root theorem is kind of tricky, so make sure to stick with me. Rational root theorem is a way to list what would be called possible rational zeros, which I know seems weird, but these will be possible choices and I'll show you how to do that with a formula. And then we test for real zeros using synthetic division. There we go. Tough to get all that in there. So again, the rational root theorem, listing possible choices for zeros if we're not given any, and then we test them using synthetic division. So the two examples at the right are kind of split up a little differently for me. It says example 1, how can you find all the possible zeros of a function? What we do is we look for key coefficients. We're going to define them as P and Q. P is going to be the constant of your polynomial. And in this example, it's 2. And I want to know, what are all the factors of 2? What are all the possible numbers that go into that go into 2? Well, there really are only two choices, 1 and 2. But they could be positive or they could be negative. So those are all possible factors for our constant. Then we need another coefficient, which is going to be our lead coefficient, and we'll call that Q. Lead coefficient. And we do the same thing. Now the lead coefficient is 3. What are all the possible factors of 3? Well, there aren't that many, which is kind of nice for this problem. Just 1 and 3, but they can be positive or negative. Now your possible zeros, the list you get, comes from taking all of the, wow, I just spelled list like that. That's crazy. All right, let's fix that quick. To create your list, you take all the possible factors for the constant divided by all the possible factors for that lead coefficient. What that means is we'll have plus or minus a bunch of different choices. I'll do 1 over 1 and 2 over 1. So that's easy enough, 1 over 1 and 2 over 1. And then I'll do 1 over 3 and 2 over 3. And lastly, we just kind of clean that up. And to clean it up, what I mean by that, 1 divided by 1 just equals 1. 2 over 1 just equals 2. But then we do have those fractions 1/3 and 2/3. Now with that plus or minus, there are 8 possible rational zeros, which seems kind of crazy. F of x is only a cubic function, which means there can be only at most 3 of them. What we'll do then to figure out what our real zeros are is we'll test those possible choices with synthetic division. I just had to fix my screen a little bit. Now, when we're asked to find the actual zeros, you want to test with synthetic division and try to figure out how to get a quadratic quotient. What that means is if you're solving a cubic function, you only need to find one real zero with synthetic division. But if you're solving a quartic, you need to find 2 zeros. And I'll show you how all that works. All right, we have our list. For this first polynomial, we said plus or minus 1, 2, 1/3, and 2/3. So now let's test them. These are the numbers we'll actually plug into the penalty box. Doesn't matter which number you start with, so I'm just going to pick 1. I'll pick positive 1 first. Now I have to go back up and remember my rules for synthetic division. All terms are present. I see 3, -4, -5, and +2. Draw a blue line. Let's see if 1 is a 0 for this function. Drop down that first term. 1 times 3 is 3. That goes up above the blue line. -4 plus 3 is -1. Times 1 is also -1. But -5 plus -1 is -6. And -6 times 1 stays -6 with a remainder of -4. That means 1 is not a 0. So here's the thing, you guys. We have to keep testing until we find one. I noticed +1 didn't work, so now I'm going to stick with 1. Doesn't really matter why. And then I'll try -1. I'll see if this can cross the y-axis at -1. Excuse me, wow, the x-axis. Let's say the right axis. Okay, draw your blue line. Let's see if -1 is a 0. Now this process can take a while depending on if we can get a 0 quickly or not. And sometimes you do even have to test those fractions. All right, 3 times -1 is -3. -4 plus -3 is -7. -1 times -7 is +7. And when we add that column, -5 plus 7 is 2. Oh, check this out. 2 times -1 is -2. We have a remainder of 0. That means x equals -1 is a 0 for this function. And again, I had to give myself a little bit more room. Now that we know that -1 is one of our answers, the quotient is going to be 1 less degree. That's 3x squared minus 7x plus 2. And anytime we have a quadratic, we're going to solve that just by setting it equal to 0. No more synthetic division. So now you can either solve by factoring or do quadratic formula. That's a D. There we go. Quadratic formula. Now keep writing vertically, right down this way, but I'm going to move my work over here to the right just because I have more space to do so. If we factor, we would have to do the earmuff method where we do A times C and then split to get B. Let's see if that works out for us. If I take A times C, I get +6. Split to get B, that means we'd have to do either 1 and 6 or 2 and 3. But to get -7, I would have to do -1 and -6. That would have to be the pair. That means I'll take 3x squared, and then I have to do -1x minus 6x, and then the last number plus 2 at the end. Then do your 2 parentheses. We haven't factored like this in a while. In that first term, we have an x in common, and that would give us 3x minus 1 left over. But in that second parenthesis, I know we have to take out the negative. What can we take out of 2 and 6? That'd be a 2. And if we take out -2, that would give us +3x and -1. That's good. Our parentheses match. That means 3x minus 1 is one factor, and x minus 2 is the other. But to solve, we need to set them equal to 0. So, or add 1 and divide by 3. X equals 1/3. And then for the other one, this one's easy. Just add 2. We get x equals 2. Recognize that we should have 3 solutions, or up to 3 real solutions, and we found exactly 3. X equals -1. We found that with our synthetic test. And we also have +2 and 1/3. Those are the zeros using the rational root theorem. Let's take a look at P of x on the right. How can you find all the possible zeros of the function? Well, in this case, I see some terms are missing and it's not written in the correct order. The first thing then that I'm going to do is make sure we have that. So I'm just going to rewrite this. P of x equals, I notice 8x to the 5th is the biggest exponent, but we're missing x to the 4th, so I'm going to put +0. We're missing x to the 3rd. We have x squared. And we have our plain x, and we have our constant. Yikes. All right, so that's kind of what the polynomial should look like with all terms present. Now remember, p is our constant, and that's the last number. That's an equal sign right there. So notice p is actually -4. If we think of all the numbers that go into -4, we're again going to do that plus or minus. I know 1 goes into 4, 2 will go into 4, and 4 goes into itself. Q is going to be our lead coefficient, and that's 8. Again, we put that plus or minus out in front. Numbers that go into 8 include 1, 2, 4, and 8. We have a lot of factors here to work with. So let's see what we can come up with for this one. Numbers that go into P over Q. Let's do that list. I'm going to take all 3 of them, I just put a bunch of dots there, 1, 2, and 4, and put them all over 1 first. So it's plus or minus 1 over 1, 2 over 1, and 4 over 1. Then I'm going to put them all over 2. 1 over 2, 2 over 2, and 4 over 2. Then I'm going to put them all over 4. 1 over 4, 2 over 4, and 4 over 4. This list is getting crazy. Last but not least, put them all over 8. 1 over 8, 2 over 8, and 4 over 8. And now let's simplify that list. P over Q equals plus or minus. I know that this is 1, this is 2, and this is 4. We won't have to repeat them. So if a number repeats itself, we just eliminate it from our list of choices. We don't have to keep rewriting it. Then we have 1/2, but then we have 2 over 2, which equals 1. So that repeats itself. We don't have to list it. 4 over 2 is 2. We don't have to repeat that one either. Then we get 1/4, 2/4, which is 1/2, 4/4, which is 1. So that works out kind of nice for us. And then we have 1/8. Oh boy. And then 2/8 is reducible to 1/4. We've already had that. And 4/8 is reduced to 1/2. So I guess I don't need that last parenthesis right there. Let's take a look at how many we have total. If it's plus or minus and there are 6 numbers, that means there are 12 possible choices. Tomorrow, we'll determine our zeros together in class.